Hi Florian.
Hello.
We are at HPLC conference today and you're presenting a poster. What is it about and why is this topic particularly relevant right now?
Well, what is it about? It's about the new features of our CAD detector that we launched yesterday, the CAD-P series. And here in this poster I want to showcase one of our new tools for method developers, the so-called temperature coupling mode. I mean, main research question was, of course, how applicable is this new tool for our customers? So I want to explain real quick what the tool does, right? So we call it temperature coupling mode, and if you're familiar with the technology of CAD detection, you can see here we have the evaporation tube going into the CDM, the charging detection module. And in our old legacy systems, basically the charging detection module was always at 40 degrees Celsius. Doesn't matter what kind of evaporation temperature you're using. And if you think about it, that might lead to problems. If you're coming in here with 70 degrees of hot gas phase or hot aerosol and you cool it down to 40 degrees, that might lead to problems, and the other way around as well. If you're coming in here to cool, hitting 40 degrees instantly, it might lead to evaporation effects. So the new feature we have is basically we couple the evaporation tube to the CDM. So therefore our customers can decide, okay, let's make an example. If evaporation tube is 50 degrees, the customer can decide, is it +1, +2, +3, +4, +5? Increment is 1 degrees, and then he can couple the CDM and basically say, okay, I'm coming in with 50 degrees, so this CDM is 51, 52, 54 degrees, etc. And that gets him way closer to the temperature of the evaporation tube. So what we wanted to showcase, to come back to your question, this was a bit long, but what we wanted to showcase is how useful is this for our customers and give them like a preview on this tool and advertise it to them. And that's basically what we did, yes.
And was there anything in your research that surprised you or stood out as a key insight?
I mean, of course, because I mean, CAD detectors are universal detectors, and that's a big plus. But it's also quite tedious, right? Because if it's a universal detector, you have so many applications to choose from. So what we did is we focused on saturated fatty acids, tinkered around with our new temperature coupling mode, and wanted to see if there is improvement. And then, of course, we could showcase that there is improvement. So we measured 4 different saturated fatty acids, and we managed to show that there would signal-to-noise ratio increase for up to 47%. And that was a surprise and great result for us. So we could stop checking for other applications, and we're ready to go here with the poster for the launch.
And how could your findings be useful for others in the field?
I mean, how can they be useful? We don't want to advertise here, this is fatty acids, use these measurements, and then everything will be all right. What will be useful is that we showcase here, this is our new tool, this is how we use it, and this is how we improved on our results. So we give our customers a new tool in their toolbox for method development. And that's one thing we wanted to showcase, and I think that will be useful for customers in the future.